Hello to everyone. We're going to wait a few more minutes until we get everybody, if there's anybody else that's late. I have you all muted, and it's been a long morning. So we'll get started here in a little bit. Make sure you have your study guide. I'm going to show the video if you haven't seen it yet. I'm going to share the video that Mrs. Starkey and Mrs. Whaley put together. All right, we'll wait one more minute. If you have a friend that you thought was going to join, let them know. We're starting in a minute.
Using like all this stuff on the side, not with us. We see you talking to the teachers alone, usually if there's something to talk about, we'll go in, go home to the teacher, and then we something private with the teacher. Because I'm friendly to
Mr. Bennett,
Yes.
do you know how I can switch it to the top camera instead of the bottom? Because it's showing like the bottom camera.
Hold on just a second. Okay, now what? Who is asking?
I was, Alyssa.
I'm not sure, Alyssa. Are you on your phone?
No, I'm on my laptop.
If you, and it's showing what like just me as the host.
Yeah, but it's like showing it as a keyboard camera. Like, and then
Alyssa, go to where it says stop video, that arrow,
Mm-hmm.
and then hit integrated webcam.
Okay. Okay.
All right, guys, I'm going to share a screen and show you the video that the teachers put together real quick. You guys see that?
Yeah. There's no sound though.
Huh, that's a math one. That's hilarious.
Okay, so what we're going to do here for the next 50 minutes or so, we're going to take some time and go over the review. I've got about 5 problems that I want to do for sure. Show you some, a lot of review, but show you some things that I think are helpful as you look at these. Maybe you haven't caught them before on the videos and the different things that you've done for research. Thursday, we'll take the test. And it'll be a time-sensitive test. There's 29 questions. I've already taken it. Like, well, I know I'm the teacher, blah, blah. But usually I estimate that 3 times the time limit that I take is going to, that's how long it's going to take you. And so it took me about 17 minutes, not quite, just a little under. But so I would anticipate if you know your stuff and you're prepared, the test is going to take you about 45 to 50 minutes. And so that's why we're giving you an hour. I think that's plenty of time. I want there to be a time restraint, and make sure that you check your technology for Pivot, that you're able to log in and you have it. So making the best of this, guys. I don't know what else to do. We've got to assess to see where we're at in circles. And I think this is the best of the worst case scenario of what we're trying to get done. So that'll be Thursday. Okay. All right, let's get going.
Uh-oh.
Okay, I've got to share screen again. That way you can see what I'm going to be writing. I am recording this, and so you can come back if you miss something. You can come back later once I get it uploaded, and I upload it to my YouTube, and then link it and put it on Canvas. All right, so you can have a chance. If you see somebody or you know somebody that's waiting, you know, please put it in the chat box or something, because I'm going to get rolling here. And I'm not going to be looking for all that for everybody. So I hope you guys are all okay. I hope your families are healthy. I know this is weird. I don't know about you, but it just so, I don't know, makes me sad. I miss normal. I miss the routine. I miss some of you, but not all of you, Layla. I'm teasing. So, all right, let me share a screen and we can get rolling here.
Oh, that's not good.
All right, there's the okay, we good? All right, so circles. Had a lot of things to talk about on circles. One of the first things I want to look at is number 1. And that's a lot of conversion. So this is Unit 6, circles. I think I have it pulled up. Let me go back to it, see if I can pull up the problem. There it is. All right. Okay. Number 1 says, which is the best approximation of the measure of angle QPS in radians? Okay, so what are radians? That is a new unit of measurement that we deal with when we deal with trigonometry and circles. All right, so coming back to this, one thing that is good to know for this test and going forward is that 360 degrees is equal to 2 pi. That is a ratio. Okay, that's a ratio. So what does that mean? That means 360 degrees around the circle is the same thing as 2 pi around the circle. Those mean the exact same thing, just in different forms of measurement or units. But they mean the same thing. And so we have to use that fact to set up a proportion that allows us to solve in this problem. So the proportion would look like this: 20 degrees to 360 degrees as our unknown, this is what we're trying to find, is to 2 pi. What is 2 pi? That's 1 revolution around a circle. When you guys get into Algebra 2 next year, you're going to spend a lot of time talking about what is universally known as the unit circle. And that is 1 circle that has a radius of 1 from here to here, and all kinds of different things come out of that. We are very elementary introducing the unit circle. That's 1 revolution. It has direction. This is the proper direction that we go around the unit circle. You can see the arrow. So 1 revolution around the unit circle is 2 pi. The degree measure of a full circle is 360. So those are in the same position of the ratio. 360, 2 pi. Our unknown is here, and 20 degrees, that's kind of the amount that we're looking for in comparison to 2 pi. So I'm not going to use the word unknown. I'm going to use a variable x. Just like any proportion that we've done since 5th grade, we cross multiply. So 20 times 2 pi is 40 pi, and then 360 times x is 360x. And then we divide by 360. And so now I have 40 pi times 360. You get my calculator on my phone. So you guys can see it. Clear 360. Clear 40 times pi is 125.6 divided by 360. And we end up with x is equal to 0.349, which is x is equal to 0.35. And I believe that the correct answer then on number 1 is C. .35, that's right. You can see my mouse. That's C. Okay, everything all right? Hold on, is there a chat problem here? Let's see. All right, we good? Thank you, Andrew, for helping Madison. All right, let's go on. Number 2, similar. We can do that fairly quickly. Let's do number 2. It says, number 2, it intercepts the same arc. So I guess it's easy to look at it. If you look at the degree measure of QTS, it intersects the same arc. So from this angle and this angle, they intersect. They intersect the same arc right here in red. So this angle, which was 20, goes to there, and this angle goes to there. So since they go to the same arc, it's going to have the same measure. So angle QPU is also equal to 20 degrees, which makes the correct answer C. So that's number 2. Number 3. All right, so arc QS, which would be this arc right here in that same diagram, it is intercepted. I'm going to write it out so you can read it as well. It is intercepted by a 20-degree inscribed angle. Inscribed angle is the type where the vertex is on the circle. So if it's an inscribed angle, it is equal to half of its intercepted arc. So if the angle is 20, then the arc is 40 degrees, which would be an answer of D. Number 4, let's see, are we doing all right here?
Mr. Bennett,
Yes.
do you know who to contact for my laptop being broken?
Send me an email, Andrew. I sent one to Mr. Allen today for somebody that needed help, and they'll either schedule a time for you to come in for Mr. Burge to look at it, something like that. But just send me an email, and we can forward it. Okay.
Okay.
We'll do our best with it. All right. Okay, so let's go back. Number 5, you know what? I do want to review number 5 just because it talks about type of circle. Let me copy down the problem. Okay, so what does this look like? Well, there's the problem number 5. Now we know that, at least you should. In fact, when I graded a lot of your 17, a lot of you missed this, okay? When I would say a lot, I would say a third of you missed this. And so the general form of an equation is this. X minus A, quantity squared, y minus B, quantity squared, and that's equal to R squared. That's the general form of an equation of a circle. Now, A and B are the center. Now, the confusing thing is that this is a minus and this is a minus. It's almost like, do you remember the distance formula? The distance formula did the exact same thing, where it's got a minus and a minus when we're finding the distance formula. So it's feels like it's the opposite. And then the R is the radius. So is R squared equal to the diameter? If I were to ask you that, is that true? No, because the diameter is 2 times R. So don't make that mistake. Okay, R squared is not equal to the diameter, but R squared is what we use for the equation of a circle. So back to number 5. So when I look at this, there is no A value in this case. If I were going to rewrite it, it would look something like this. Because there is no A value. And so that means the A value in this case would be 0. And the B value in this case would be positive 4, not negative. Because the basic form tells us that that's a negative and that's a negative. If that happened to be a positive, like y plus 4 quantity squared, then it would be a negative 4. So A is 0, B is 4. That makes the center at 0, 4. And then the radius is equal to, this is R squared. We take the square root. We have the radius is equal to 5. So there's the basic info. The center, 0, 4, and the radius is 5. And I think that gives us an answer of A. Okay. Any questions? Okay, let's keep going. All right, let's go the other direction. Let's take a look at number 6. Number 6 says we have 9 and -5 and a radius of 1. Again, this is a +9 and a -5. So what that would look like would be x minus 9 quantity squared plus y plus 5 quantity squared, and then a radius squared. 1 squared equals 1. So that's 1. All right, number 7. Let's copy down the problem. A circle has an area of 100 pi square miles. Wow, boy, that's a large area. What is the circumference of the circle? Okay. So 100 pi square miles. Now, that's area. We know that area is equal to pi r squared. If you don't know that, you should have it memorized. Pi r squared set equal to the area. Now we solve for r. We have pi on both sides. Those would cancel out. So now I have 100 is equal to r squared. I take the square root of both sides, and 10 is equal to r. That's not our solution, but we got to find that in order to find our solution. Circumference of a circle, we have 2 formulas for the circumference, 2 pi r or pi times diameter. They are the same thing. So I know what r is. I'm going to put that in and solve for circumference. 2 times 10 is 20 pi units, which I believe then is a correct answer of C. All right. Okay, so not sharing right now. Does anybody have any questions at this point? We're going to do more. I still have more problems to do. But up until what we've talked about so far, any questions? Haley, any questions? Seth? Abby? Layla? Garrett? Hunter? Hi, Emerald. Okay, let's move along. You know, some of the other problems, I think, you know, they deal with some of the formulas of proportions. And so how to set up a proportion and solve is critical for these. So that's what we're going to spend a lot of time doing next. All right. All right. So let's take a look at might as well just keep going. Number 8. Let me share the screen and take a look at number 8. I'm going to point out some things without recreating the picture with my mouse so you guys can all see it, I hope. Okay, so here you see a circle and it says the length of SU. Where is SU? Okay, there's SU. It's a little bitty segment right there where my mouse is tracing. That is unknown. So this is 1.5, which would be TU, and UQ would be 4, and WU is 3. Okay. So if I'm looking at two chords that intersect each other, one of the formulas or properties of chords intersecting each other is that you can multiply the parts of the chords and they're equal to each other. They're in proportion, they're a ratio. Okay, so let me focus in that a little bit. Okay, so that's what it looks like if I were just going to draw it freehand, which, by the way, when it comes time for the test, you need to have some paper ready on Thursday, because some of the questions, you're going to need a picture to kind of clarify it in your mind, just as I'm doing right now. Okay, and so the equation that this creates is we take 1.5, the part here, times the other part, which is 4, and then that's equal to the unknown, which is what we're trying to find, and times the part that we know. So it's actually a fairly simple equation now. And so we multiply and we divide. 1.5 times 4 is 6, and then 3x, and then we divide by 3, and 2 is equal to x, which I believe then gives us an answer of A. Okay, so just a simple proportion. Now let's take a look at 9. Let me come back to the, see if I can, yeah, there we go. My eyes, older I get, not very good. But let's take a look at this one, number 9. What is the best approximation of PX? PX is from the outside the circle. So P all the way to X. By the way, what is that called? That's called a secant. A secant has 2 points of intersection that goes through the circle. What's the difference between a secant and a chord? A chord is inside the circle. So SW is a chord, TQ is a chord, but PT would be a secant. That's the difference. What about a tangent? A tangent only intersects a circle in one spot. Usually it's outside the circle. Okay, so looking at this, PR is outside the circle, and PX is the entire secant. So that's the part of the theorem that's important. The portion that's outside the circle, PR, times the entire thing. And that's equal then to PQ times PT. Okay, so there's my equation. PR, I think that is 3. PX would be 3 plus X. That's the entire secant. What does X represent? The portion that we don't know. That's the chord on the inside. Okay, what does PQ equal? That's the part that's outside the circle. That's 2.5. And then PT, all right, how did I get 8? Let's go back and look. 2.5, use my mouse here. 2.5 plus 4 is 6.5, plus 1.5 is 8. I add all the parts together. So the entire secant is 8. Now we multiply and solve. 9 plus 3x is equal to 20. 3x is equal to 11. And x then is equal to 3 2/3. That's not the answer, though. I believe they're asking for the length of px, right? Which is the entire thing, where x is just the part on the inside. We have to take 3 2/3 plus 3, and so we get 6 2/3 for our answer, which is B. All right, how we doing? Good? We're down to 20 some minutes, so I wanna keep rolling here. Let me check, see if anybody has any questions on the chat, anything. Nope. Okay, good. Okay, let's skip number 10. Hopefully you figure that one out. Let's go to number 11. Here's a picture. Hopefully it helps understand the problem. It says there's a degree measure of 15. I believe that's a central angle. And then it has a radius of 8 and an arc length of x. Okay, so an arc length of x. Okay, so we know that 15 is to 360. This is where the proportions are so important, because it's not a full circle. It's just a little bit of it. It's 15 degrees of it. And we're comparing this to the length, not the area, but the length around a circle. Okay, that's in radians. Now remember, that's the circumference. So the circumference in this case would be 2 pi r, which is 16 pi. Okay, so circumference 2 pi r. We take the 8, we put it in for r, and circumference is 16 pi, and that's where I got that. Now my unknown, which would be just the little bitty arc, just this arc right here, that's my unknown. We're going to call that x. Cross multiply and divide. So 16 times 15. Ooh boy, what is that? 225, 240. So 240 pi is equal to 360x. And now I divide by 360. And so we have x then is equal to, let's get the calculator going. You guys see it okay? Blur is not too bad. Okay, so we take 240, well, let me clear. 240 times pi divided by 360. And I get 2.09 is equal to x. Did they tell us to write it to the nearest tenth in the directions? Yeah, what is the length of the intercepted arc to the nearest tenth? Okay, so I would say then that the length of the arc is 2.1. All right, good. Key learning is this proportion. 15 degrees compared to the entire. So like this is just a little bit of the part of the circle. It's not 360 degrees. It's not a full circle. This is the full circle. This is not a full circumference. This is just the part that is proportional to the full circumference. So you have to be able to check. You have to be able to set up that proportion, okay? And then cross multiply and solve. Okay, some of you had a question on number 12 back when we turned in the homework, or you were working on, we didn't turn it in, but we were working on this review. And here's what I'm going to tell you about number 12, and this should be enough that, let me write it down. A tangent line is perpendicular to a radius, or I'm also going to say diameter because it doesn't matter as long as it goes through the center of a circle at the point of what we call tangency. Okay, so what does that mean? Well, if I make a crude picture here and I have a tangent line, oh no, hit it. And not a very good tangent line, but where it touches the circle is 1 point. And if I take a radius, it's 90 degrees, always. Okay. All right, and then for 12 and, well, for 13, if you have a quadrilateral, the opposite angles are supplementary. So that should help you on 13. All right, let's take a look at 14. Okay, what's the area of the circle? Area is pi r squared. Okay, so is it that simple? So we know that on this one, the radius is 5, and so 5 squared, 25 pi. Do they want us to round it on this one? Because that's pretty simple. What is the area of the circle to the nearest square of inch? Sure do. So if we multiply that out, 78.5. Got it? All right, let's do at least one more, one with the sector. So let's do number 15. All right, so if I have a circle and I'm trying to find the area of a sector, that's the area of a pie, an apple pie. Sounds yummy. An apple pie, this piece of apple pie, how much area is it? Well, we know that the area of a circle, of a full circle, is pi r squared. Okay, so we don't want the full circle. We only want a part of it. We only want a piece of it. We only want a portion of it. So number 15, if that's P, and I believe this angle in here is 70 degrees. I don't know if you guys can see that or not, but that's 70 degrees. So instead of 360 degrees, which would be a full circle, we want a part of circle, 70 degrees. Does that make sense? How we're always setting up a proportion? Honestly, those of you in chemistry, you should be pretty good at this because you got to do a lot of proportions. Well, I mean, it's a lot of the same math. Okay, so 70 over 360. And then hold on. All right, Haley, I see your question. Hopefully I answered it. If not, send me an email later. Okay. All right. So 70 to 360. And then, okay, so wait a minute. What? Oh, yeah, we got to go to radians. Okay. So we want the area using pi. Usually, if it's in terms of pi, that means it's in radian mode. Let me say that again. If it's in terms of pi, or if it has pi working at all in the problem, that means it's in radian mode. Okay, so a full circle, this has a radius of 5, would be 25 pi. That's the area of full circle. Okay, does that help you? Does that make sense? So I've got part of the circle here, the full circle here. I'm going to end up putting a part of the circle here. Actually, it's called the sector. And then the area of the full circle. All right, so we're going to not use that phrase. We're going to use x because that's our unknown. And we're going to cross multiply. 70 times 25 pi over 360 will give me the area of the sector. Just multiplying them out now. That's that ugly number. I'm going to divide that by 360. And so I end up with 15.27 or 15.3 units squared. And that's equal to the area of the sector. Okay, so let's go back here. Which one was that? 15, that takes care of that one. Hey, if that's a central angle, look at my mouse here, where my cursor is, 75 degrees. If x is 75 degrees, what's the arc WY? 75. Remember, the central angle is equal to its intercepted arc. So if that's 75, then what's this angle, WZY? Remember, it is half of its intercepted arc. What's half of 75? 37.5. So number 16, 37.5. I'm not writing it down. You should know it. 18 and 19, those are supplementary problems. Just take x, let me use the cursor, x and x plus 20, add them together, set it equal to 180 for supplementary. Solve for x. Okay. All right, how we feel? Do we feel better? Nod your head, no or yes. Give me a thumbs up at least. Miranda, a little bit better? I can't see everybody on the video. So, okay, thank you, Noni. Good. Let me give you a little insight for the test on Thursday. Here's an example. I remember this problem because Hunter, it is like a baseball problem. Okay, so here we go. Here's an example. I'll share in just a second. Let me set it up. Okay, so it's like a baseball problem. Like this is the left field line. This is the right field line. And let's say it's, I don't know, 300. I truly don't remember the numbers here. But let's say that this is 300 and this is 300, which is like the radius of a circle. And they say, okay, that's the question. It's not that exactly, but it's like that. So it's like a baseball diamond. You've got 300 feet down left field line, 300 feet down the right field line. What's the length from here to here? Well, that means it's in radian measure. And so this is 90 degrees. That means it's 1/4, because 190 is 1/4 of 360. So I could set up a proportion and go 90 is to 360, 300, if this is circumference, because it's length, not area, there's a difference. You know what? That's a good thing to remind you of. Length is circumference. Area is different. Those aren't the same. So circumference has direction. So 90 is to 360. Circumference should be 2 pi r. So in this case would be 300 times 2 pi, or 600 pi. And then we would cross multiply and solve. So you see how that's very similar to what we were just doing? The difference on the pivot is sometimes it's the same type of problem, but it's worded weird or differently. And so that's why I'm telling you, have some paper, because you may need to do this, or they may have a picture and you might need to copy the picture down. I'm not saying do it every time, because sometimes it's really obvious. And in fact, there was a couple that I thought, you don't need to waste your time, just answer it. I mean, you can see it directly. I would say the 29 problems, 16, 18 are multiple choice. There's a couple, the other ones are fill in the blank and, round it, like very similar to what we were just doing. How some of these were finding it, rounding it to the nearest 10th, things like that. Okay. Okay. Anybody else? Any questions? Good. All right. If you have a question, you run across something on this review. By the way, this review is due. You got to turn it in. So I guess I didn't clarify that today, but we do need to turn it in. Now it'll be moved to Thursday because that's when the test is. And then we'll start next Monday. We'll start conic sections, which means ice cream cones, spheres, cubes. I don't know. I thought of this idea. You guys tell me what you think. I talked to my wife about it. Yes, Haley, yes, you can. I talked to my wife about it, but we'll set up shop somewhere. I don't know. You guys know where we live off of Mechanicsburg Road? So like out by the road. Well, Mechanicsburg Road, I'd send my address. It's not that big a deal. But we would set up by the road or out by the trail. And because I normally do this during class, give away some ice cream cones. We'd have to do social distancing. I mean, I'd wear my mask, gloves, give you an ice cream cone. Emerald, would you like that? No? Layla, would you drive by to get an ice cream cone? Hunter, don't be riding together now, 6 feet apart. Abby, you can run by. All right. I hope you guys are doing okay. And I know it's crazy time. It's different. Never experienced anything unprecedented like this. I'm sorry for you guys. I do. I feel sad for you. Just because not normal. It's just not normal. So, all right. Well, I hope you guys, your families are healthy. Hope your grandma and grandpas, the people that are a little bit more susceptible to getting this. I'm not quite that old. I know I may look like it, Seth, but I'm not. I'm not in that age range, Garrett. But those people that are, be careful. Stay away from them. So, all right, guys, that's it. It takes a little while for this recording to kind of upload, but I'll get it as soon as I can, and you can share it with and see it, look at it, all that good stuff. Any last questions? All right, bye. Wave at me. All right, bye, guys.